So in this video, I want to talk about the definitions and derivatives of hyperbolic functions, okay? And just a quick brief overview. We say the definition of sine hyperbolic of x, well, that is just e to the x minus e to the negative x divided by 2. We say we define cosine hyperbolic of x to be e to the x plus e to the negative x divided by 2. And we define tangent hyperbolic of x to just be cosine of x divided by 2. Cosine of x, sine of x, sine hyperbolic of x divided by cosine hyperbolic of x. And when we do that, you'll see that we'll lose our 2. So this becomes e to the negative, e to the x minus e to the negative x. I'm just going to simply divide that by e to the x plus e to the negative x. So those are the important definitions that we need to know. I don't think your teacher will allow you to memorize any more apart from these three, which are the most important. So now let's talk about the derivatives, because this is what this video is really about. So I have this function here. So f of x is equal to sine hyperbolic of the square root of x. Okay, and before I even touch that, I need to point out something here real quick. Okay, I need to point out the derivatives. Okay, and so dx of sine hyperbolic of x, well, that happens to be cosine hyperbolic of x. Okay, we need to know that. Okay, like similar dx respect to cosine hyperbolic of x. Well, now because we're dealing with hyperbolic functions, it so happens that when we take a regular cosine derivative, well, we say that is negative sine of x. But in this case, it's going to be positive hyperbolic. It's going to be positive sine hyperbolic of x, okay? So we need to know those two. So with that being said, let's take some derivatives. So we have this function f of x is equal to sine hyperbolic of the square root of x. Well, f prime of x in this case will be, well, what's the derivative of sine hyperbolic of x? We just said that was cosine hyperbolic of x, but since we have the square root of x, we know that's just the square root of x, and we're going to multiply that by the derivative of the inside, okay? Just remember this has an argument. So what's the derivative of x to the 1/2? Well, that happens to be 1/2 x to the negative 1/2. And again, this is just something we could just leave like that. How about this one? F of x is equal to cosine hyperbolic of 2x plus 1. Well, if I look at this, what is my derivative? Well, in this case, we know f prime of x. The derivative of cosine hyperbolic of anything is just sine hyperbolic of that same thing. So we know this is sine hyperbolic of 2x plus 1. And then again, we should recognize that this has an argument. So we're going to use the chain rule in this bad boy. And so we know the derivative of the inside is just 2, because derivative of 0 is 1. Derivative of 2x is 2. So we know this is multiplied by 2. So again, put in my constant in front. We know derivative is turned out to be 2 sine hyperbolic of 2x plus 1. Okay, so this will be my answer. So let's look at another one. So what if we wanted to take, what if we have f of x, some function f of x is equal to natural log of sine hyperbolic of x, okay? So this is sine hyperbolic of x. What would be my derivative? Well, again, we know the derivative. So this f prime of x in this case, we know derivative of natural log of anything is just 1 over that thing. Okay. So in this case, this would be 1 over sine hyperbolic of x. Okay. And then I'm just going to multiply by the chain rule. Well, what's my derivative of sine hyperbolic of x? Well, it happens to be cosine hyperbolic of x. Okay. And again, I could leave it like this, but let's simplify. So if we simplify a little bit further, we have cosine hyperbolic of x divided by sine hyperbolic of x. So we know in this case our derivative can be simplified to cosine of sine hyperbolic of x. That is simply cotangent hyperbolic of x. Okay. Let's look at the last one. Again, these derivatives are fairly easy. So if we have a function that we define to be f of x is equal to sine hyperbolic of x times cosine hyperbolic of 2x. Sorry about that. Well, now I'm looking at a product, okay? And so if we call this u and we call this v, we know f prime of x in just those notation will be the derivative of u times plain old v plus plain old u times the derivative of v. Okay. And so if we call this u and we call this v and we follow the formula, then we know the derivative of sine hyperbolic of x happens to be cosine hyperbolic of x. We're simply just going to multiply that by cosine hyperbolic of 2x. Okay. And we're going to add, well, what's my plain old u? That happens to be sine hyperbolic of x multiplied by the derivative of cosine hyperbolic of 2x. Well, we know the derivative of cosine hyperbolic of anything happens to be sine hyperbolic of that same thing. And then again, don't forget we have a chain rule here. We have an argument here. And so the derivative of the inside now happens to be 2. Okay. And again, I could simplify this further to say, okay, well, my actual derivative is cosine hyperbolic of x times cosine hyperbolic of 2x plus 2 sine hyperbolic of x times sine of 2x. Okay, and all I did was just put my constant in front because it makes it looks better. Okay, so again, nothing difficult. It's just the basic idea that we should know.